யாருகிட்ட பேசுறேன்டி நான்
अच्छा है ना मुझे इसमें சொல்லணும் ஒன்னு கிடையாது அது இல்லனா பண்ணிட்டு அந்த டிபார்ட்மென்ட் எக்ஸாம் வச்சிருக்காங்க ஆர்எஸ்கேல பிரைமரி எக்ஸாம் ஹை ஸ்கூல் மிடில் ஸ்கூல் எக்ஸாம் வச்சிருக்காங்க இன்சார்ஜ் அந்த இன்சார்ஜ் போடு
नहीं वो ना 4:30 बजे वैसे ओरिजिनल टाइम तो हमारा 4:30 ही है जिनके साथ मैं जाती हूँ ना उनका 1 घंटा एक्सटेंड हुआ था आज वापस 4:30 हो गया 5 से 4:30 ही रहेगा पूल करती हूँ ना मैं आजकल गाड़ी नहीं लेके जाती 110 रुपये पड़ता है एक दिन का क्या माड़ा है हाँ मेरा 250-300 रुपये कर
Hello. Hello. Hello.
Yes, sir. Kriparan, sir. Good evening. Good evening. Welcome. Welcome.
Good evening. Good
welcome,
evening.
Sir.
Are you able to hear
welcome.
me?
Very much welcome. Very happy to receive you.
Thank
good
you.
evening to everyone.
No,
Shall
are
we
you
start
able
the
to hear
program,
me?
sir? இது PowerPoint போட்டு பாத்துறீங்களா அப்படி?
கேக்குதா?
கேக்குது. Your voice is clear. PowerPoint போட்டு பார்த்தலாமா? PPT வந்து போட்டு பாத்துறீங்களா? உங்க ரைட்ஸ் உங்களுக்கு பாருங்க.
Okay. No, you are able to hear me?
You are able to hear you, sir.
Okay. Now I'll do one thing. இப்போ நான் ஷேரிங் போணுமா?
ஷேர் பண்ணுங்க. வருதான்னு பாத்துக்கலாம். We'll start the program.
Okay.
Sir, make it full screen, sir.
No, You're able to see my screen
Yeah. You're able to see your screen. Yeah.
and hear my voice also.
Okay, unshare பண்ணிருங்க. Then we will start the program. Then you can, after that you can present. Unshare பண்ணிருங்க.
Okay. One minute.
Okay, sir. Thank you, sir. We will start the program, sir.
Okay.
Sir, Saravana Kumar, sir. Good evening. Dr. Saravana Kumar, sir.
Yeah, good evening.
Good evening. We will start the program, sir. Yeah. Good evening to everyone. Today we have an interesting topic, that is, happy good evening to everyone. Today we have an interesting topic, cyber security challenges for common man through wind turbine generators. This is going to be talked by an eminent speaker, our past chairman of Computers of Trichy chapter, former AGM of BHL, and Dr. E. Kirban. Today presently is a director, Mrs. Grace College of Engineering, Thuthukudi, Tamil Nadu. And we, IEI Tichapalli, first of all, we welcome Dr. Kirbaran sir to our program. Thank you very much, sir, for accepting and deliver towards cyber security today. Thank you so much, sir. And we, IEI Tichapalli Local Center, we regularly conduct the program for the past 3 decades without interruption. Before the pandemic, it was in physical mode at Dr. APJ Abdul Kalam Hall, located BHL campus in IEI building. And after the pandemic, we switched over to virtual mode. This is our 174th program. This is what. And we, IEI Tichapalli Local Center, regularly conduct program to propagate the emerging technologies to our members, societies, and our students, faculties, our industry experts, everyone, to large to the society. That's what. Our service is continuing. And our Tichapalli Center is situated right from Ariyalur, Perambulur, Karur, Pudukkode up to Nagapattinam, except in Tanjore. And we have corporate members more than 2,500 and student members have 7,500 members. And today's program is organized by G20, Government of India. There is the G20 conference is going on. There's awareness we are creating through our Saravana Kumar is ambassador for Tamil Nadu. He is taking care of the awareness program about cyber security. And today's second program, last month we had a program, this is second program. And this program is organized by IEI Tichapalli Local Center in association with the G20, that is Government of India, Information, Electronics Department, the Information Technology Department, and Computers of India Trichy chapter, that Indian Institute of Welding Tichapalli branch, Indian Institute of Welding Society Southern Zone, Indian Institute of Metals Tichapalli chapter, Indian Institute of Industrial Engineering Tichapalli chapter, Indian Society of Non-District Testing Tichapalli chapter, Indian Institute of Metals, and Kumari Ariel Paravai. These are the institutions joined today with us to propagate this program. And with this small introduction, I call upon Mr. Saravana Kumar to introduce the speaker to the audience. Over to Engineer Saravana Kumar, sir. You can tell about the G20 program as well as introduce the speaker, sir. Please, sir.
Sure. Thank you. Very good evening to all of you. Iniya Malai Vanakkam. On behalf of CSI G20 team, I welcome you all for taking time away from your busy schedule to attend this session. As part of our Ministry of Electronics and Information Technology, that is MEIT's G20 Stay Safe Online Campaign, Computers of India in association with IEI Tichapalli Local Center is conducting this awareness program on cybersecurity challenges through wind turbine. And this session has been organized with the aim of creating awareness about the potential cybersecurity threats that can be posed by wind turbine generators. As we all know, wind turbine generators are an important source of renewable energy and are becoming increasingly popular all over the world. However, with the increasing use of technology in these generators, they have also become vulnerable to cyber attacks. A cyber attack on a wind turbine generator can cause significant damage to the generator itself, as well as to the power grid that it is connected to. So the main purpose is to educate the common man about the possible cyber threats and challenges that wind turbine generators can face and how we can prevent them from happening. Our expert speaker, Dr. Kribakaran, will provide insights into the latest cybersecurity measures that can be taken to protect wind turbine generators. I hope that by the end of the session, you will have a better understanding of the importance of cybersecurity in wind turbine generators and how we can play some sort of role in ensuring security and safety. So now it's my pleasure to introduce our esteemed speaker, Dr. E. Kribakaran, for today's online session. Dr. Kribakaran is currently the director for Grace College of Engineering, Thuthukudi. Earlier, he had held key positions as additional general manager for BHEL Trichy and had also served as professor for Computer Science and Engineering Department of Karunya Deemed University, Coimbatore. He completed his BE Honours in Mechanical Engineering at NIT. Earlier it was REC Trichy, and subsequently joined BHEL Trichy. He has also completed his ME and PhD in Computer Science, both from NIT Trichy. He has also completed his MBA from IGNO. At BHEL, he was involved in design, development, and implementation of various computer-based systems, and retired as additional general manager. He had been a visiting faculty for various education institutions, board of studies member, and member in academic council in many education institutions. He had also guided many research scholars. Dr. Kripakaran had held the post of secretary, vice chairman, and chairman for Computer Institute of India Trichy chapter. He had been nominated as syndicate member and advisory board member of Bharatidasan University and member of the academic council of Anna University. He had also been a member of the governing board of many colleges and was also the chairman of governing board of the prestigious Government Arts College of Kumbakonam. Now, over to Dr. Kripakaran. I am quite sure that all of you would enjoy this session. Over to Dr. Kripakaran.
Thank you, Dr. Sarvana Kumar, for excellent introduction. So now the platform is for you, sir, please.
Thank you, sir. Thanks for the nice introduction, and thank you very much, Mr. Selvaraj and Mr. Sarvana Kumar, for inviting me for this. It's a pleasure for me to share my thoughts on this area.
Your audio doesn't seem to be very clear. Maybe if you could hold the mic near, or you could go near the mic, that would be great.
Is it now?
It's okay, but it could be better.
Wait, 1 minute. 1 minute.
Thank you.
Please check up. Is it sufficient now?
Yeah, you're loud and clear. You're loud and clear. Thank you so much.
No, I will go ahead. I hope you can manage.
Yeah, we are able to hear, sir. Please go ahead, sir.
Hello.
Yes, sir. Now the audio is
It's okay.
Please proceed.
okay.
Okay, I'll
Manage it.
right. Yeah. So we'll see about the challenges of common men through wind turbine generators. So I'm thankful for this opportunity. It's a premier for economic cooperation. It is an important role. It plays an important role in shaping and strengthening the global architecture and governance of all major international economic issues. And India holds the presidency of the G20 from December 1st, 22 till this 30th November. And the priorities of G20 are, during India's presidency, Meeting will focus on 3 priority areas, namely digital public infrastructure, cyber security, digital skill development, with Stay Safe on Online campaign and DA program under the Digital Economy Working Group. So the cyber security framework model, that main functions are to identify the cyber threats, to protect, to detect, to respond, and to recover. So we have to be cautious enough to identify what's happening, to protect in case something happens, to detect, respond, and recover. Now, before this, I just want to give an overall trend, how the technology was evolving for the over years. First thing is, we'll all know about the steam engines and other things. When mechanizing was the main improvement or main development. People used to manually do all these operations. Once everything was mechanized, then came this advantage. There were mass production, your transportation was faster, like steam engines came, like this it happened. That and all happened in somewhere in 1700s. Then next important thing was the invention of electricity. It is called Industrial Revolution 2. Earlier, the power, it's available only. Now with electricity, it can be generated and it can be given to various places. And that way there was a great improvement. The next revolution can be that Industrial Revolution 3, where computers, including the internet, space, electronics, and all those things came. That can be somewhere in 60s. So computers, including the internet, now where we are is the industry with the Industry 4.0 standards. You can say that there are some disputes here, but still we can say that this is Industrial Revolution 4. Many agree, some do not agree. It is as per the implementation of Industry 4.0 standards. So this we can call it as an Industrial Revolution 4. So for many people, Industry 4.0 is the fourth industrial revolution. It is accepted. However, some people still disagree. You can say that it starts somewhere in advanced stages of internet and other things. One thing I wanted to share is this wind turbine had been a source of energy right from the very long times. We can see the Egyptians in some like 2000 BCs, they used to use wind power for sailing the ships. Then came the wind turbine. Some 9th century, 13th century, this was a type of wind turbine. This is still there. It is in Netherlands. Netherlands, people used to shift at water level. This was used as the main source of energy. There are two types of windmills. One is the vertical axis, another is the horizontal axis. Horizontal axis was the popular one, and there also exists vertical axis windmill. In this context, I want to share you something. When I was studying my engineering mechanical in NIT Trichy, we made a project. Design and fabrication of vertical axis wind turbine was our project work. And the ruins or, the remains of that particular thing, the post and all, still lying in the top of the mechanical engineering department of NIT Trichy. Well, this is a vertical axis wind turbine. This is how it will look like. Now, where do you locate these windmills? There are some pockets of places where wind energy is available in a large quantum. Two important places in India are, one is the Kanyakumari or that Kanyakumari belt or the Aralvaimali belt, where there is a lot of wind available. Another is the Gujarat area. They constitute the maximum amount. And this is one of the things in Aralvaimali wind belt. You can see a lot of things in Aralvaimali wind belts. The height of this, we'll come to the slides. These windmills are located not only on the land, it is offshore also. In the ocean also it is kept. A group of windmills you can see. The installed wind energy capacity in India from 2009 to 2021 has grown to a large extent, from 40,000 megawatts to 10,000 megawatts to 40,000 megawatts. And the government of India is giving a lot of emphasis for this non-conventional energy, that is the wind energy and solar. And wind energy has got very good potential, particularly in places like Tamil Nadu. The installed capacity has gone so much from 10,000 to 40,000. The individual turbine, the capacity was ranging. We still have capacity ranging from 250 megawatts to 4,000 megawatts. This 4,000 is a very recent. There are windmills more than 30 years old in our own places, like this, somewhere around this 250 megawatts turbines and all. And height of the wind turbines ranges from 50 meters to 200 meters. You can imagine what is the height of 200 meters. Like, I think our football ground will be somewhere around 80 meters or whatever it may be. Normal windmill, the height will be around 100 meters. This 200 meters is the higher side, that 4,000 megawatt. One more thing is, it used to be located at remote locations. But the problem is, once it was remote, and now that 30 years and old windmills, if you look into this thing, so many houses and other things would have come here. Of course, there is a restriction. In order to keep a windmill, there is a formula. You have to, like, the size of the windmill, or like there cannot be the land area you have to acquire. I'm not very sure about the dimension. It is something like that, 2.5 into the diameter of this area, that the land size has to be provided for each windmill. In other words, approximately, even if the windmill falls down, it will not hurt people. Falls down as such. The typical windmill now, it is something like this. So the wind is blowing. Usually there will be 3 blades. The speed of there will be one particular shaft attached to this thing called the main shaft. It will be running at the speed of around, say, 15 to 20 RPM, revolution per minute. Then the gear system makes it to run about 1,500 to 2,000. So only this generator can work. Then there is a controller unit. It is very important. This controller unit is provided by the original equipment manufacturer, which we call it as OEM. It will govern all these activities. When to start. There are so many activities which will show this particular thing. And then the power is given to the grid. Power can be either given to the grid, or if you want, you can use the power for your own requirement. Say, for example, I am having a particular thing. I am having a windmill and I want to use it for my company. You can use it. Or I want to give it to the government and from the grid, you can use it. So the concept of the stuff is like this. There is the wind. The wind power makes the turbine rotate, and there is a gearbox. So this wind power is converted into mechanical energy, and this gearbox generates sufficient speed, and it is running the generator. There is a power, and it is connected to the grid. And there is a control system which covers all these areas. There is a system called SCADA. It is a computerized control system. The basic thing is, it gets all the sensors at what speed it is, what is the wind speed. Anemometer will give the wind speed. What is the temperature inside the gearbox? What is the electricity that is generated? What is the grid position? Now will it generate it or not? Or should we apply brakes and stop it? All these things are done by the control system. So this is an overall block diagram of the typical windmill. So this is an aerodynamic system which converts the wind into, actually the shapes will be in an aerofoil shape. Then it will come to mechanical, then to electromagnetic, and to electrical. The top portion is called nacelle, which is situated at a height of about 100 to 200 meters. And here, if you look into this thing, there will be blades. Inside, there will be gearbox. There will be brakes to control this particular thing. Then there will be oil pressure. There will be fault detectors and all those things. There will be 2 important movements that is happening. One is the yaw movement, which will yaw drive. It will move the entire nozzle. Nacelle is called this position, which is covering all the components of the windmill. It will rotate the entire yaw drive with respect to the vertical axis, and there will be also a pitching which will rotate about the axis of this blade. So these are the 2 things. It takes care of the wind direction. Suppose wind is coming in one direction, it will take it in this particular thing. It will move accordingly to adjust to the wind direction and make the best use of it. This is again the same thing. Pitching is this particular movement, and yawing is this particular thing. This is the main shaft that is coming from the blade. Gearbox, there can be a single stage or multi-stage. So it increases the speed and it drives the generator, and there will be a controller. Anemometer measures the outside wind. And there will be so many other things like the temperature measurement, pressure measurement, and all those things. So this is so these are the functions. The blades, they are exposed to the wind. On attaining the record wind speed, then it will start rotating. Beyond the particular speed of the wind, also for safety reasons, the blade has to automatically stop by the control system. This point will take note of that. We will see that suppose the blade does not stop, what will happen? Because our topic is how public is affected by this cyber security. So this point, please note down. The purpose of the blade is it has to run at a particular, when it reaches the speed, it has to start running. Then only it can run also. Otherwise, it has to suck electricity from the grid. Our intention is to provide electricity to the grid. Okay, it has to start rotating and the controller will decide when it has to start rotating. Beyond a particular speed of the wind, for safety reasons, the blade has to be automatically made to stop. That is the purpose of the control. Suppose there is an intruder, how we can play with this particular thing? That is the cyber security. Shaft and generator, it is a mechanical energy. These blades are attached to the main shaft. The rotational speed is very less, normally less than 20, and it has to be made to 1500. Generator and power interfaces, they are connected to the generator, helps to connect to the electricity to the grid. And there is a control system. This is basically a supervisory control and data acquisition system. You can see it in so many modern machines, this SCADA. So it takes all this. Please note down, even before Industry 4.0 standards or Industrial 4th revolution, they were having SCADA, but the type of SCADA it was having was slightly different. Now there is a lot of advancement. How it can interact with the internet, old SCADA and the new SCADA are different. Accordingly, we have to take into note of the cyber security, which receives input from the, so this SCADA receives input from the sensors like temperature, pressure, sensors, gas sensors, and all these things. Whatever happens inside, it takes, and accordingly it has to act. So this is a block diagram of how the various sensors sense from the wind turbine, the position, the speed, acceleration, stress, strain, temperature. See, there are so many things. There may be a cable when it is rotating this way and that way, the cables will be getting stressed. Everything, the fluid, what is the viscosity of the fluid, what is the temperature of the oil there, what is the lube oil which we apply to the bearing, how is it, and all those things will be sensed. And the control system takes care of this particular thing, and the communication and reporting. Communication says, come on, now we can start. Now power can be produced. Now there has to be an emergency shutdown. All these activities are done by the controller. So sensor sense what is happening, activator acts. These are the basic things. This is an IoT. So basically, there will be a lot of sensors inside this particular thing. All will be connected to the controller and they will be managing the show. Now, again, these are some of the details of how we are getting it, how using your application controls, how based on this particular thing, the pump, the heaters, and the filtering, the pitch, and all those things are taken care. So this SCADA, if you look into this thing, it is nothing but a computer. You can see this particular thing. The SCADA network is there. It used to get all the signals from various things. And through firewall, it will be also communicating what is happening to the rest of the world. So these windmills are also connected through the internet, which we will see some of the slides, what we can try, we can get to know from this particular thing. So this windmill act like a smart factory. It is a mechanical factory, but whatever happens inside, it is also communicated to the rest of the world through internet. There lies our security problem also. If it is mishandled, what it will happen? How the common people will be affected? Not only windmill owners getting a loss, how an ordinary person can be also affected. That we will focus on this particular thing. So with this particular understanding, the windmill that started in the 9th century as a simple device to pump water. Of course, that was the first industrial revolution. Subsequently, also in the second industrial revolution, it was used to generate electricity. Windmill used to be connected to the electric generators and it used to generate electricity. Third industrial revolution also, it used to be connected to the computers and we'll know what is happening. The fourth industrial revolution, that is the Industry 4.0 standards, lot of minute works, still finer works we are starting to do it using this same windmill. So this windmill has sustained over a period of, what do you call, so many years, and still it is producing. Now it has become mostly a smart factory in the sense it is fully based on computers. So what are the Industry 4.0s in this particular thing? IoT and IIoT, industrial IoT for sensing and actuation. What is this IoT? They can also act like a mini internet servers. So what is required, it can pass on to the next portion. So this is low, you stop it. So it can also act as a small internet device or a small computer device having its own memory and all those things. Networking, there are numerous types of networking that has come. Earlier, client will be there, server will be there, they will be connected. Now, there's a fog networking, there's an edge networking, and ultimately everything is connected to the cloud. The networking has become complex. The once you say complex, there are a lot of advantage, and unless you are strong enough in the cyber security, it can also cause a lot of problems. And the new emerging field, namely artificial intelligence, big data, machine learning, deep learning, all these things has come into being, and they are studying the behavior. So, analytics of data analytics. Now, I'll give a small analogy. Here we have an OEM, original equipment manufacturer. He will give some standards. Say, let us say we buy a car. When you buy a Maruti car, the Maruti service station will say that, sir, 5,000 kilometers, you have to change oil. Then this particular thing, you have to do this particular work. Then you have to do your wheel balancing on this particular thing. Either when the car runs this kilometer or this time elapses. Like this, they will give some standards. Original equipment manufacturer will also, of the windmill will also give some standards. But here what happened is, let us take an example. You have a car. Let us say you are driving in BHL township, just 2 kilometers from the township to the office in a good road. Another person uses the same car and drives in a rough road for 5 kilometers or the same 2 kilometers in another place. So the way the car is getting affected is different. This place as well as the other place. Similarly, the windmill, one may be erected in a place in Nagarkoil, another place may be in Gujarat, another will be in Rajasthan, where the ambient temperature will be different, where the turbulence will be different, where the moisture content will be different. Accordingly, the way it is affected will be also different. The way in which the yawing and the pitching happens also may be different. Accordingly, the cables, how it has to be affected is also different. To start with, maybe using a gear oil of a particular type. Now you may be using a different brand of oil. So the time in which we have to change that oil also may be different. What happens is artificial intelligence, machine learning, deep learning, data analytics and all, they help us for this condition, which is the best. For the particular windmill that is put it in this action here, what is the, what do you call, what is the mechanism maintenance we have to follow? Such things are decided efficiently if you use this sort of things. This has come into being only recently, for the past 1 decade only. This is an industrial 4th revolution. Okay, and one more thing is cloud computing for connectivity. All data is stored in the cloud, because when you have this big data and other things, voluminous amount of data is generated. So in order to handle this voluminous amount of data, we need cloud. Sometimes you may be having large amount of data. Sometimes it may be, the windmill may not be running in a particular thing. So I need not spend my resource. So you pay as per use. Cloud helps. So this sort of setup is there. And Industry 4.0 is embedded into the wind turbine now. So what we'll understand is, as it goes, now incorporating all these particular things of the latest development, wind turbine is behaving in a different manner. It is acting as a smart machine. Why you need a smart machine? What is an ultimate purpose of this making it smart? Then we should have an increase in operational efficiency, increase in safety, increase in transparency, what is happening, increase in productivity. There has to be cost cutting. It has to be reduced cost cutting. Unnecessarily, we should not spend on what do you call maintenance. And in a simple way, what we can tell is the best cost cutting is there should not be any breakdown maintenance. What is breakdown maintenance? Unexpectedly, the windmill has stopped. You go there and look, something has gone. Suppose there is a preventive maintenance which takes care of these things. Preventive maintenance can be on two things. One is this time you follow, so many days you change this. Sometimes it may be more expensive also. So this preventive maintenance, there is a condition-based maintenance that the data analytics will do. For my windmill, for this particular condition, this is the right time to do this operation. It's the right time I have to do this operation so that there is a preventive. That is, I can avoid a breakdown. If all this happens, the employees will be satisfied. Both the internal employees as well as the external employees, the agencies or the owners, everybody will be having an overall satisfaction. So that is, with all these things, the windmill act as a smart factory. So these are some of the parameters. Normally, what is the position of the axle, how much current it is generating, how much it is exporting to the grid, how much it is importing to the grid. Sometimes to the start, we will be also taking some power from the grid. What is the angle of this particular thing? With all these things, there will be some fault also. It will say that sometimes there will be an alert and warning, minor, major, critical. It has to analyze things. It's the repetitive nature. Often this same thing happens, then what we should do. And all those things are happening. I'm giving a small example about an actual windmill. This thing, there is a company called RS Windtech Engineers Private Limited. It is working in RLY Milling, and they are maintaining almost around 800 to 1,000 windmills. If you look at the glance of this particular thing, in various screens you can see whether the windmill is generating. If I click this particular thing in an actual live environment, it will show right now. Today, how much it has generated till this time? What is the wind speed? So many meters per second. What is the rate at which it is generating? So this is a particular. This is generating, and there's a grid drop. Grid drop means right now we are not. EB is telling that I don't want the power right now, so you don't send it. There's a freewheeling. Freewheeling means some wind is there, but that is not sufficient to run your machine. So it will give an overall idea how this is at time. All the windmill, whatever you are having, all these things are taken into computers. It is to be a web-based system. These things are generated. One thing we should remember is, in order to physically go and see the places, it's very difficult. So this is one thing. And inside this particular thing also, let us say on 1st February, I have taken every 5 minutes, what is the ambient temperature, what is the temperature at the various places, here the oil temperature, etc. What is hydraulic pressure, what is the vessel angle, what is the line voltage and line current, what it was doing, what was the wind speed, how much electricity it was generated, and the time in every 5 minutes it was given. These are some of the reports taken from the live web-based system, computer system that is monitored. Then the turbine monthly report, parameters report. Then monthly report. This is a very important thing. One power graph. What is this power graph? The original equipment manufacturer will say that on this particular wind speed, if it is 11 meters per second, it is supposed to generate so many kilowatt of power. Let us say 550 kilowatt of power. But how it is generating is only 450. So there is something called power graph that is available, which will be recorded. By knowing this thing, I will know that whether my windmill is doing a proper this particular thing. All these things are made possible by this computer SCADA system equipped with a web-based system in order to do this. Suppose we want to enhance it further. The information system, we want to enhance it further. Now, the SCADA data, we want to do, you can do some algorithms and models. You can do a lot of, what do you call, analysis, and you can try to get more information. Through human-machine interface, it will be conveniently made available. And through maintenance strategy, this is a very important thing. As I told earlier, the maintenance strategy will tell that for this particular windmill, this is the condition. It is, you can say that it's a condition-based maintenance strategy. Can be three things. One is as per the original equipment manufacturer, it tells once in this period you do this thing. Second is depending on the conditions what we are monitoring, we can do. And third is condition we observe. Third is the condition we predict by this data analytics. Still we can do the maintenance management. Real-time condition monitoring system. What all the sensor that is required for the gearbox, generators, rotor blades. What is the techniques that we will follow? What do you diagnose out of this particular thing? Whether the gear is under fault or the bearing is having some problem, the damage, fatigue, and all those things it is seen. So by using this data acquisition and analysis, that is, you are taking all data relevant to this. What all the data that is relevant? The wind speed, the direction in which the wind is blowing, the turbulence of the wind, the moisture of the wind, the variation of the speed, plus what all the sensors that is happening inside this particular thing, the oil temperature, the oil pressure, the vibration, frequency, and all those things that is happening inside. So taking into account of all these things, you do a condition monitoring. So you take data acquisition, you process it, you take what all the features, you extract the features. It is all this machine learning, and you identify what is the fault, or you do a preventive maintenance. There are two maintenance you can do. You can do a corrective maintenance or a preventive maintenance. Something has gone wrong, we correct it after a fault. Preventive maintenance is before the fault happens, you try to prevent this particular thing. Then here it will run into this thing, whether it is a provisional or whether it is a permanent this thing. Then it is systematic, condition, forecast maintenance. All this data analysis will help you in the forecast also. So sort of a hybrid information system, which takes the SCADA, which takes one more thing. The original equipment manufacturer will provide a lot of information, but we, for our condition, we may provide some more information also. So we can take the data, we can process it, we can build a hybrid information system. Some information has to be given to the owners, something to the maintenance team, something to the statutory authorities also. Whether your windmill, your vibration is within the norms, whether the sound is within these norms, and all those things. Okay, these are some of the offline things. So here inside there are a lot of tests we are getting data. Apart from that, there will be also some more information which we have to get it by other means. It is not by automatic means. So other means like this boroscopic cable, whether the cable is twisting or something like that, some visual inspection also has to be done. Now coming to the aspect of this particular thing is whether we are able to run it in an efficient manner, whether your downtime is reduced. We don't have a downtime, it is machine is down or anything. Whether we are operating at the correct way or are you operating below the rated power condition. These are the things which have to be calculated. So this is Like each windmill will have a power graph. So this windmill, after this particular thing, it runs, whatever it happens, it cannot increase the power. So like this, now coming to the security aspects, this is what we want to do. Some research work has gone on this particular thing, windmill, and they have seen that what are the probable risk. There is a research done by Jason Stack's Computer Research University of Tulsa. They have done some research. So insecure programmable automation controls. See, all these things are controlled by programs. Suppose your program is insecure, it can lead to a great damage. The information that is passing on, it is not having sufficient encryption. See, some person who controls the windmill is at one place, and the control is coming to this particular thing, RLY Mali in another place. The message has to properly control with a sufficient encryption. Otherwise, it can lead to problem. Network segmentation between the turbines. If these things are not proper, it can cause great problems. These are some of the security concerns. This is one researcher has told. This researcher has told that computer science researchers in the University of Tulsa, according to the German security researcher, this person has found, in one case, a hacker could have gained complete administrative access to the turbine and possibly change the wind vane direction or change the network settings to access the web interface that would make it inaccessible. So, if there is a possibility in a particular setup, if an intruder is able to have your complete control over this thing, when the wind speed increases, the vane has to rotate to suit the wind direction, he can change it. So, a malicious hacker, there's a possibility, there's a potential problem if there is a problem here. This is the most important thing which I want to say. Another researcher, cyber intrusion of wind farms, SCADA system, what is the impact it can have? It can make overspeed of the wind turbine and equipment damage. This paper thoroughly analyzed the cyber security aspects of the SCADA system of the wind farm by incorporating the impact of power system damage. The vulnerability of the wind farm are identified. The simulation results show that cyber attacks can cause major problems to our power system, including economy loss. Economy loss is the windmill is not generating electricity to that extent you are losing. That is one thing. Overspeed of the wind turbine. The wind turbine is supposed to stop at a particular wind speed. If it is not made to stop and if it overspeeds, suppose there is a storm and the windmill keep on over speeding, what will happen is the entire structure may break. The fans may be thrown off. We do not know how much it can be thrown off. As I told earlier, there's a particular norms that the windmill, the turbines, what do you call, the height of the wind turbine has to be on a particular, the area around the wind turbine has to be. But what will happen is, in a particular storm, if the wind speed is not controlled and it is allowed to overspeed by an intruder, the fans can be broken and it can be thrown off at a distance. The damage that can cause to a common man, common public, that is possible. So, these are the security concerns. See, what happens is, now that windmill has become a smart system. And the smart
somebody please, could you please mute the person who's singing?
And smart system is very nice. It is able to do it in a very good manner. It is able to produce good electricity. And one more thing we can do is, till now, the government has not told very particular about windmill. It has to run only for 20 years or 25 years. After that, you have to dismantle. Like that, they have not told. There are a lot of issues. This once again I compare with the car. Ambassador cars. See, I got my Ambassador car of 1989 model, which I still prefer to have it. Still, it is in running condition. I may prefer it on particular thing, but I have to be careful on certain things. Like I should not overspeed it, or I should think it. Similarly, a windmill also may be running, but only thing is the security and the safety level should be sufficient. It should be there. And one more main problem is, suppose you want to replace this windmill. It is a 250, 250 megawatt windmill erected 30 years earlier. And I want to convert it into a 750 megawatts windmill. For 250 megawatts windmill, say 6 acres of land will be sufficient. For the next generation, 12 acres of land will be required. In the same place, I may not be able to. Why may not be? I will not be able to get that 10 acres of land now. Because near the place, so many other things would have come. So what will happen is, I cannot modify, take this and reinstall another thing. Because then I have to go to another place. Another thing is, dismantling this windmill is also a great problem. And the returns you may be getting may not be much. So like this, there are a lot of problems. So windmill owners try to adhere to the safety, try to make the windmill run in such a manner that it will produce enough electricity according to the power graph, and also take care of the safety measures by following all our Industry 4.0 standards or the Industry 4 regulation. One thing we have to be always careful is the type of problem the windmills can have if not handled properly. As a typical example, one thing is the overspeed. Another thing is, suppose there is at times when there is a threat for fire, the windmill will automatically stop. Suppose that you leave it, even if there is a threat for power, purposely you leave it by a cyber attack. Again, the damage can be unimaginable. Forest area like thing, one windmill catches fire, would not. So a cyber threat can lead to problems also, unless otherwise it is properly taken. Of course, there are so many agencies looking into this particular thing of how to have the security over the how to increase the cyber security. So also G20 forum also has got its own agency for this particular thing. Cyber security priorities of G20 is an exclusive area that is dealt by this particular thing, how to take care of this. Well, I thought I'll just share some of the concept of windmill, the advancement of windmill over the period of time, and how you have to be secure to take advantage of this thing. Any technology, what will happen is, when there are an advantage, there will be, unless you handle it carefully, there will be a disadvantage also. Any technology for that matter. A sharp knife, it may go well, but if you don't do it carefully, it may cut your hand also. Your device like a computer or a mobile, it will be very much useful, but when it is misused also, it can be this thing. So similarly, the windmill right now, the wind energy is subjected to Industry 4.0 standards or Industry 4 revolution. We handle it, it is very nice, and it is an encouraging energy resource. Government is also giving lot of priority, but this cyber threat and all, we have to be careful, and we should not just think that cyber threat is left only for these people. Only for the people, the owners, ending with a loss of revenue, but it can be for the public also. I think with this, I complete my talk. Anybody else has got some doubt, they can ask. I'm not an expert in this area, but I was interested in this area basically. And we were also working along with a windmill company, how we can enhance the MIS of management information system of this.
Dr. Kribaran sir, good evening.
Good evening, sir.
How are you, sir? I am Karpasamy.
Oh, so nice.
Sir, I got one question, sir.
Huh.
In the case of solar power generation, that generation capacity and that installed capacity is very vast difference is there. For example, for 1 megawatt capacity, 0.15 megawatt only is the generation capacity like that. We got an inference. What about the wind power generation, sir?
So, power generation depends on the speed of the wind you are able to it, sir. In the power graph, you can see that power.
Who is not talking? Could you please go on mute?
Sir, now you proceed, sir. Kribakaran, sir.
Yeah. Yes, sir.
Tell me, sir. I could not listen to because of the crosstalk.
Okay. See, I'll just request. Is one Mr. Koil Play Prabhakar there in this group right now? Why I am asking is, he's a man, he's a managing director of this who handles both wind. He's the one MD of this RS Windtech. He handles wind energy as well as solar energy. They install both. Okay. So he'll be able to give a finer aspect on this thing. But what I understand, I mean, honestly speaking, I don't know much about solar energy. But here what happened is, it is very much tied up with the wind speed. If the wind speed is sufficient, or if the wind speed is in this range, so wind speed, what will happen is, the wind speed is there. Actually, this is taken in the month of August, so it is nice. If you take another graph in the month of January, it will be only to these things. Okay. So even in the best region, this is taken in the Arulvaimali region. So it is like this. So and around 4 months, practically there will not be any wind to run this particular thing. Solar in other areas, it is much better. Then
4 months they will shut down the wind power windmill, sir.
No, they will not shut down. It's
they
not.
Will do some maintenance, something.
They will not do zero. I mean, they will not totally do, but the main maintenance they will take.
Okay,
there will be some generation. It's not that it is zero generation, but there will be a vast difference. That's what I'm telling. All the major maintenance they will take it up.
Okay, sir. Then what about that generation capacity and that installed capacity? No, how much it will come? It is depending upon the wind speed, sir.
Sir, that depends on the wind speed. Yes.
Sir.
Okay. See, even in the
hello.
Yeah, that depends on the wind speed and the location. See, even in the best season, let us say July, August, there are times when there will not be any wind also.
How much they will reach? That
hello.
I'll do one thing. I can.
Hello.
How much they will?
Hello. Am I audible? Hello.
Yes, sir. Yes, sir. Tell me, sir.
Mr. Prabhakar is talking. Hello.
Sir. Sir, actually, the wind, if it is very good, you will get a plant load factor of 40%. So 40% is the efficiency you can say. Solar, you get 15%. Wind, you can get 40%. 40% you get. Whereas if it is offshore, that is on the seashore, if you are going to put wind turbines, it is going to generate throughout the year, throughout the day. So because you have the sea breeze and land breeze, so it will be running all the time. So in those cases, you get 60% efficiency.
Okay. Seashore area 60%, other areas 40%, sir.
Hello.
You mean seashore area 60%, other area 40%?
The 60% what I'm talking is peak efficiency.
Yeah.
40%. And wind you will get, that is when the wind is blowing at the rated speed, say for 20, that is each turbine, it will have its own rated speed. Like 7 meter, if it is a class 3 turbine, then it will have 10 meter as a rated speed. If it is a class 2 turbine, then it will be 12 meter, its rated speed. So if the rated speed is there means, then it will be able to generate 100% power. That is a 1 megawatt machine will produce 1 megawatt So it is
Okay.
not like solar. But only thing is it won't generate all the time.
Okay, sir. Thank you, sir.
Yeah, when you have the
Thank-
peak wind, then it will generate.
Thank you, sir. Thank you.
Kapusamy,
Tell me, sir.
the one Mr. Koilpillai Prabhakar who was giving this answer is maintaining 1,000 windmills.
Oh, thank you, thank you. You
I know.
are just
Thank you very much, Mr. Prabhakar, for the useful information.
Sir, Kirbaran sir,
Yes, sir.
you can unshare the screen. It was an excellent presentation, sir. Very nice. We are able to get a lot of information about the basics to what are the security threats and all nicely explained by you. Thank you so much. And there are a lot of questions in chat box, sir, for you. How relevant is the turbulence apart from the wind speed? When Narayan Govind asked, how relevant is the turbulence apart from the wind speed? The chat box you can see.
Yeah.
When Mr. Narayan Govind asked about how relevant is the turbulence apart from the wind speed and what is wake losses? These are all questions. Engineer Anurag Prasad.
Mr. Prabhakar, Koilpillai Prabhakar. Hello?
So Prabhakar? Yeah.
Yeah.
There are
Can-
questions.
Look into the chat box also. I think.
hello.
There are some questions, Mr. Prabhakar. There are some questions in the chat box. How relevant is the turbulence apart from the wind speed? And what is wake losses? There are questions asked there.
What is the? Just a moment. Give me 5 minutes time because I am driving actually right now.
Okay, no problem.
Mr.
You
Tarun
can
Kumar,
ask me.
sorry, I made a mistake. This kilowatt, not megawatt, as you write.
And there are a lot of appreciations for your presentation, sir. The people have appreciated your efforts.
Sir, I am Ilango here.
Yes, Ilango, please talk, sir. Please talk.
Sir, is there any possibility for installing 4,000 megawatt wind turbine in Kanyakumari belt?
No, there is one windmill recently inaugurated somewhere. Installing it 4,000. Not megawatt. Please change everything as kilowatt, not megawatt. It is installed somewhere very recently in Kanyakumari district. It is installed.
Sir, what is the cost?
So the highest capacity right now installed is 5.2 megawatt in Mundra. Mundra 5.2 megawatt has been in.
But it has been developed up to 4,000 megawatt, it was told.
No, sir. 4,000 maybe many power equipment they have installed, sir.
It may not be with one power
one
generator.
Unit. Many units they might have installed.
Total number of units.
Rated capacity. Adding
what is the rate of installation, sir, per megawatt? Cost of installation.
1 gigawatt is equal to 1 crore. That was the thumb rule. 1 gigawatt is equal to 1 crore. That was the
1
amount.
crore. It was the initial proposal.
And
till now it is maintaining.
Your question of another installing in Thoothukudi on this sea, 30 gigawatt power bank, wind power bank is coming. Inside the sea, within 1.5 kilometers sea belt la 30 gigawatt today from Rameswaram to Thoothukudi today belt la ithinadu varapodu. Adu already nama State Department has announced proposal போட்டிருக்காங்க இந்த பட்ஜெட்ல. If it is offshore na 15 gigawatt wind energy, it is 2030 la அவங்க plan.
2030. Subsidy கொடுக்கிறது வந்து still they are maintaining. Government of India is giving the subsidy for
அடுத்த ஸ்டேஜ் போயிடும். இப்ப இருக்க சப்சிடியோட ரேட்டை காட்டிலும் வரப்போற காலகட்டத்துல
ஹலோ,
வரப்போற காலகட்டத்துல subsidy will be totally different scheme, and it is going to be hybrid mode. Hybrid mode it is going to be there, and we need not worry about this. The only thing, capacity, how to improve the capacity and the wind energy bank. அது எப்படி கொண்டு வரது பெரிய ப்ராப்ளம்.
Thank you sir, thank you so much.
ஓகே, thank you. கருப்பசாமி போகுதுல்ல? கருப்பசாமி
சார் சொல்லுங்க சார்.
கிளாரிபிகேஷன்
கேக்குது சொல்லுங்க சார்.
கேக்குதா? இல்ல நான் நினைச்சேன் இது கேட்கல நினைச்சிட்டு இருந்தேன்.
இல்ல நான் கேட்டுக்கிட்டு தான் இருக்கிறேன் உங்க இத.
சரி சரி.
மிஸ்டர் பிரபாத்
போனதுல சொன்னாங்க
வே கிளாஸ் WAK clause. WAK clause. Yes. Yeah. Somebody has asked, can you please explain?
The WAK clause is something where that is the wind after hitting a turbine, it loses its its effectiveness. So it needs to, the wind has to regenerate itself before hitting the another turbine. So usually what we do is we space the turbine in, that is 7 times that of the rotor. So 7 times that of the rotor. So suppose the rotor diameter is 700 meters, that is 100 meters means, then 700 meters will be the distance between the first turbine and the next turbine. So the wind hits this turbine, regenerates itself in the when it travels 700 meters and then hits another turbine. See, this depends upon the size of the turbine. Suppose if you are having a turbine which is having 30-meter wind, that is diameter of the blade means, then what happens is it will be 7D. So it will be 210 meters will be sufficient for it to regenerate the wind, because it hits a smaller object, so the wind can regenerate itself better in a quicker manner. So the wake field is managed in the turbine placement planning. But sometimes what happens is when you cannot, then you lose lot of space. What people prefer is they go even for 3D or they even go for 5D. So it depends that upon the planning done by the customer. But if his internal machines means he can plan it in his own way. But if it is going to be another customer who is going to put the next turbine means, obviously he will try to put it 7D from the first turbine.
Mr. Selvaraj, one small thing is the certificate link being provided.
So,
Mr. Selvaraj?
Sir, yes, sir, please tell, sir.
Is the certificate link provided? People are asking.
Yeah, that will be after vote of thanks, sir. After vote of thanks.
Okay.
After vote of thanks only it will be placed. That's what I am replying to the individuals.
Okay.
No, still formalities are next week program announcement. Vote of thanks. Finally, it will be placed.
Okay.
They will allow 15 minutes for filling and getting the certificate. That's not issue.
Okay. Prabhat, one more thing. How relevant is the turbulence compared to the wind speed?
see, turbulence is a sudden change of speed of wind. Turbulence is a sudden change of speed of wind. That is, sometimes what happens is when you have an obstacle like a mountain or something, you will have the wind hitting it. Directly also wind will hit the turbine, and through that is an obstacle also, you will have a secondary kind of wind coming, or suddenly there will be an increase in the speed of wind, and suddenly there will be a drop in the speed of wind. So this will affect the performance of the turbine actually. That is the control system has to be robust, and when the wind speed, it is not only about the wind speed, sometimes the direction of the wind also will change suddenly. When you have suppose if it is near to a mountain or something of that kind. So that time what happens is immediately it needs to shift, and because the turbine runs facing the wind. So when it has to rotate immediately, or suddenly the wind is not available. So this causes turbulence.
No, with respect to the power it generates, how it is affecting?
Yeah, obviously the power will get affected because power gets generated when you have a constant stream of wind. Say when you have a rated power, say if it is 7 meters, that is if the windmill has a cut-in speed, say in 4 meters, it starts generating. For 4 meters per second of wind, it starts generating. Means that is the cut-in speed, it starts generating. And when it is reaches 12 meters per second, means then it contains the rated power. If it is a 1 megawatt turbine, means it starts generating 1 megawatt. So it is. So if the wind speeds goes to, that is the wind speed and the wind direction, if it is going to fluctuate, means what happens is obviously your power curve will be affected. And if it is happening in a quick succession, it is just like switching off your AC and turning it off. Why you need a stabilizer? Similar kind of thing. So the control system gets affected in a big manner.
Transient. What do you mean is a transient. Transient surge, your control system should take care of. If the control system may not be so robust to take care of such a sharp turbulences.
Yeah. So
whereas in a steady state condition, control system will automatically keep it up.
Every system is inbuilt. The IGBTs and everything are capable of handling it, but but at what cost? At the cost of efficiency. So obviously the machine will slow down. It will go to. It will wait for some time to switch on. So when it waits for some time to switch on, it will consume power. So you have the reactive power increasing. So all these things has to be managed with respect to turbulence. That is why they will not put turbines at where the turbulence is more, or you have to go for a different class of turbine.
Yeah, good evening. Can I put one question? Do we have windmill with blade angle auto change? Do we have auto blade angle change windmills in India?
No. What you are talking about is the pitch angle. The blade itself rotates. The blade, that is not only the blade rotates, it is like the moon, it rotates on its own, and also it rotates around the planet, that is Earth. Similarly, the blade also rotates. It does not rotate to such an extent that 360 degrees. It rotates 1 or 2 degrees, it rotates.
Can we call that as a blade angle, or we should call only as a pitch angle?
Pitch angle. We call it as pitching of the blade. Pitch angle. Yes, sir. We have a separate control system for that, and pitching control system controls.
But what is the torque required, for to make that blade movement? What is the torque really required?
Sir, actually it varies. Actually, the torque, we don't study it in that angle because only the IEC document contains the torque value. So normal maintenance and in this field, we don't study the torque that is. We only look at the torque that is used for the Newton meters that is used for torquing the studs of the blade. So what torque is required for the blade movement, we don't study that.
But how do we actually, how do we size the servo motor?
No, that goes in the design of the wind turbine. Because here we are talking about maintenance of turbine. That goes into the design of the wind turbine. The EC document for wind turbine contains those details as to how the wind turbines are designed.
Okay, I was only looking for sizing the servo motor if the pitch angle is more than 5 degrees. Thank you.
Okay, sir. Okay. Right, sir. Right.
Thank you, Prabharan sir. It was an excellent talk by you. Really enjoyed your talk. Thank you so much for giving the basics to what are the threats involved. And there is a big way. Our Tamil Nadu is having more than 800,000 kilometers seashore. We are expecting a lot of power plants, wind offshore, onshore, and all. Already is there. There is a megawatt percentage also, megawatt capacity also big way. The European countries increased. So there are thinking going on 5 megawatt, 10 megawatt, 20 megawatt single unit like that. Things are going on. And see, we are going to see a lot of power plants, our windmill generators, our seashore. Like from our sources also shared with the budget is being proposed like that. It is a good thing. We have to learn a lot about it, and it's a nice talk by you, sir. Thank you so much. Now, moving on to the next agenda. Our secretary is held up in a meeting. I'll announce next week's program. Next week's program is performance of industry sector. It's going to be delivered by the Mr. Vinod Kumar. Vinod, deputy manager from BHL, is going to deliver about. I request all the participants to participate and get benefited, and we will send through email and WhatsApp message also. And moving on to the next agenda, that is vote of thanks. I thank all the VIPs and dignitaries throughout India and abroad also. Thank you so much for their presentation. Now I request Dr. Titus sir to propose vote of thanks. Over to Titus sir.
Okay, sir. Thank you, sir.
Yes, sir.
Very good evening to one and all gathered here. I am happy to deliver the vote of thanks on behalf of IEI Trichinopalli Local Center. And also I thank the organizer for giving me this opportunity.
Titus sir, 1 minute. Dr. Saravana Kumar sir, do you want to say anything? Saravana Kumar sir?
No, nothing from my.
Right, sir. Right, sir. Thank you. I did not ask you. That's what. Okay.
Yeah, I know it's a great session. Thank you. Thank you.
Right, sir. Thank you, sir. Thank you so much. Saravana Kumar is a former director of Cognition Technology Solutions India, and he is presently ambassador for G20, propagating the cyber security awareness. This is the second program we conduct through IEI and CSI, and we will continue this program every month. That's what. Okay. Thank you, sir. Thank you, sir. Now over to Dr. Titus, sir. Please, sir.
Okay, sir. Thank you. Okay, very good evening to one and all gathered here. I am happy to share, deliver this vote of thanks on behalf of IEI Trichinopalli Local Center. And also I would like to thank the organizers for giving me this opportunity. First of all, I would like to thank today's chief guest of this program, Dr. E. Kirubagaran sir, Director of Grace College of Engineering, Thuthukudi. Sir has given a wonderful lecture on cybersecurity challenges for common man through wind turbine generators. Nowadays, the power from the renewable energy sources, wind energy and solar energy plays a major role. So, in that, sir has given in detail about the operations and the various things which is related to wind turbine generators, and also the security issues of the wind turbine generators, and also the industry 4.0 plays a major role in this industry, that is in wind turbine generators. In addition to that, sir has explained in detail about that how the IoT and cloud computing plays a major role, how the deep learning and the machine learning and all data analytics, all those things are elaborately sir has explained. So once again, on behalf of IEI Trichinopalli Local Center, I take this opportunity to thank today's chief guest, Dr. E. Kirubagaran sir. Thank you, sir.
Okay, thank you, Dr. Titus. So, Titus, sir, please place the feedback link, sir, to the chat box. Okay,
sir, thank
please,
you,
please.
Thank you.
Thank you very much, sir, for everyone participating today. Really, we enjoyed. It's a very good session today. Thank you so much. Thank you, Saravana Kumar, sir. All the dignitaries throughout India and abroad also. Thank you so much. Now the feedback link will be placed on the chat box. You can fill the feedback link so that you will get the certificate in your inbox. That's what. So with the permission of all of you, we will call up the day, and whomever is wants the certificate, they can fill the form, feedback. So the feedback link is provided on the chat box. Kindly fill it. So you will get it within a few minutes. You will get your certificate in your inbox. Thank you, Prabharan sir. Kirubagaran sir, excellent session, sir. Thank you. We enjoyed session. Thank you so much. Thank you so much. Good night to everyone. Good night.
Thank you, sir. Thank you.
Thank you.
பிரபாகரன் சார். இவரு கிருபாகரன் சார் லைன்ல இருக்காரா?
பிரபாகர் லைன்ல இருக்காரா என்ன தெரியலையே. அவர் போய்
இல்ல ஒரு டவுட், whether we have to do any periodical maintenance like non-seasonal time இருக்கு இல்லையா?
ஆமா.
Whether we have to rotate the turbine daily basis or weekly basis with some torque, we have to go on move the shaft.
கருப்புசாமி, நீங்க எந்த ஊர்ல இருக்கீங்க?
நான் திருச்சியில தான் இருக்கேன்.
திருச்சியில இருக்கீங்களோ? சரி சரி. இல்ல, ஒரு அக்கேஷன்ல வந்தா கூட ஐ கேன் அரேஞ்ச் டு ஷோ எ விண்மில். வந்து எப்படி
வரலாம் நான் பிளான் பண்றேன்.
சரி, நான் கனெக்ட் பண்ணி கொடுக்குறேன் உங்களுக்கு.
நான் அதை முடிஞ்ச உடனே கூட பேசுறேன்.
சரி, ரைட்.
ஆறுமுக பெருமாள் கான்டாக்ட் பண்ணாரா? டாக்டர் ஆறுமுக பெருமாள் கன்னியாகுமரி.
ஆமா, பேசினாரு அன்னைக்கு. பேசினாரு.
நான் தான் நம்பர் கொடுத்தேன். ஓகே ஓகே ஓகே. Thank you. Take care.
கருப்புசாமி சார், கிருபாகரன் சார், we can arrange an industrial visit சார். சாரோட பிடிச்சி ஒரு இண்டஸ்ட்ரியல் ஐஇ மூலமா இண்டஸ்ட்ரியல் விசிட் போயிடுவோம்.
பண்ணிடுவோம்.
அதாவது இந்த செஷன் இந்த இயர்ல பண்ணுங்க.
பண்ணிடுவோம் சார்.
Yeah, thank you sir. Thank you.
Okay sir. Thank you. Thank you.
சார், நீங்க உங்க சிஸ்டர்ல கன்சர்னுக்கெல்லாம் கொஞ்சம் சப்போர்ட் பண்றீங்களா?
எதுக்கு சார்?
உங்க சிஸ்டர்ல வின் டர்பைன் எல்லாம் வச்சிருக்காங்க இல்லையா? வின் ஃபார்ம்.
இவங்க இதான்.
அவங்க இவரு பிரபாகரதா?
ஆமா.
அந்த இதெல்லாம் நீங்க அசோசியேட் பண்றீங்களான்னு கேட்டேன்.
இல்ல, இந்த ஒரு மேனேஜ்மெண்ட் இன்ஃபர்மேஷன் சிஸ்டம் அப்படின்னு ஒரு இந்த இதுக்காக
எல்லாம் ஆலினால் உங்க சிஸ்டம்ல தான் பண்றாங்கன்னு எனக்கு நியூஸ் எல்லாம் இருக்குல்ல.
எங்க சிஸ்டம்? நேர்ல பாப்போம் கருப்புசாமி.
சரி, வர எங்க வீட்டுல அவங்க 2 பேரும் அடிக்கடி பேசிக்கிட்டு இருப்பாங்க. உங்க சிஸ்டர்லாவும் எங்க மிஸ்ஸஸும்.
ஓஹோ, சரி சரி.
நேத்து இன்னைக்கு ஒரு 1/2 மணி நேரம் பேசிக்கிட்டு இருந்தாங்க.
சரி சரி.
Thank you sir for giving the very valuable நிறைய new information we got it from your presentation.
அப்படியா? ஓகே.
ஆமா. இப்ப ஜெனரலா விண்டர் பெயின் பேசுவாங்க. இந்த ஆபரேஷனல் இஷ்யூஸ் எல்லாம், அந்த நிறைய டெக்னிக்கல் இஷ்யூஸ் எல்லாம் இன்னைக்கு நீங்க டச் பண்ணீங்க.
இந்த பிரபாகரன் தான் ரொம்ப வசதியா போச்சு. ஏன்னா he can இந்த ரியலாவே கொஞ்சம் இதுல அவர் இன்வால்வ் பண்ணிருக்காரு, பண்றாரு.
ஆமா. அவரு ரொம்ப அவர்கிட்ட நிறைய கேள்வி கேட்கணும்னு நினைச்சேன். சரி, வேண்டான்னு தான் நான் அவாய்ட் பண்ணிட்டேன். ஓகே. Thank you.
ஓகே.
நமக்கு டைம் போலா.